In a previous video, I showed three useful financial functions in Excel: future value, present value, and NPV, or net present value, although that function doesn't actually calculate net present value. I want to show you three more here that are really quite useful: the PMT, the rate, and the end period function. And the reason I want to do this is what I find is students are oftentimes using formulas to do the calculations, which is useful to do the first time or do it a couple of times just so that you understand how the problem is solved. But even students who use Excel tend to type the formula in. And the problem with that is it's very tedious and you can make a lot of mistakes. And in fact, as I was preparing this video and I was trying to solve these out, I found I had a hard time getting the right answer with these, because if you don't put the parentheses in the right place, you get the wrong answer. So it's so much easier to use the PMT function. So the PMT it's an annuity. That's what the PMT stands for. And an annuity is a stream of equal payments made at equal intervals. So for example, a mortgage is an annuity, right? You pay $1,000 a month for 30 years, and you might want to figure that out. You might know, hey, I borrowed $300,000. I want to know what my payment is going to be, given whatever the interest rate is and the terms of the loan, right? 30 years monthly. You might also have some amount you'd like to grow to. So a future value. So I'd like to save, in my example here, it's going to be $100,000, and I'm going to do it over 20 years. If the interest rate is 10%, how much do I need to save each year? Now again, these formulas work. This is what's programmed into the calculator. But as I said, I was typing these in, and I was actually going to demonstrate this with the actual formula, but I kept messing it up so many times, I said, it's just not worth it. The beauty of the PMT function is it's the same function for PV and FV. You just put in different values. You put in the rate, number of periods, the PV. If you're just doing PV, you won't have an FV. And the type, 0 is for an ordinary annuity. That's what this formula is. And 1 is for an annuity due. Ordinary annuity means first cash flow is 1 period in the future. An annuity due, first cash flow is today. So normally we do ordinary annuities. The difference in the formula would be you would multiply this value by 1 plus the interest rate. So we're not going to do that now. Most things are done as ordinary annuities. All right, so let's solve these. Okay, suppose, for example, you want to save $100,000. and you want to do it over 20 years at an interest rate of 10%. How much do you need to save each year? Well, let's use the PMT function. PMT asks us for the rate. And again, it tells you down here. I typed it out here because it's hard to see this, but it tells you what to type in. So you don't have to remember what order. Number of periods. It asks you for the PV. We don't have a PV here. We have an FV. So I'll put a 0 in. And I'll put in the FV, and we want it to be an ordinary annuity, so we'll skip the type, and I'll close the parenthesis. So you need to save $1,745.96 every year for these 20 years, and that will grow to, at 10%, $100,000. Suppose you have $25,000 and you'd like to take it out over 20 years in equal amounts. If the interest rate is 10%, how much can you take out? Again, let's use that PMT function. What's the rate? 10%. Number of periods, 20. Okay. We have a PV here of 25,000. We have no FV, so we can just skip that. We just close up the parentheses. So you can take out $2,936.49 every year over those 20 years. The second function I want to show you is the rate function. Again, you can solve for it algebraically. There's a formula here. In fact, this isn't quite as tedious, so maybe I'll do this one using the formula, and then I'll use the function that Excel has. And again, it tells you what to put in. It has one more number here, a guess. You don't really have to put anything here if you don't want. Okay, it'll still figure it out. Okay, so let's see here, right? So basically I'm saying I have an amount of money, $300. I've put it in the bank. I want it to grow to 1,000, and I want it to do that in 5 years. So here I use T, that's the number of periods. What rate do I have to earn? So let's put the formula in. This one I can probably do. So here I'm going to have FV divided by PV, okay, and I'm going to raise it to the power of 1 divided by T, and I'm going to subtract 1. And I get 27.23%. So that wasn't too bad using the formula, okay? Not a lot of parentheses because we're not dividing by a bunch of different things, okay? Or I can use the rate function. Rate, number of periods. We have no payment. Now, you have to be careful here. You have to put the PV in as negative. And the reason you have to do that, it's the way Excel works. They're on different sides of the equation. The way to think of it is you're putting money away, so it's a cash outflow, and the future value will be a cash inflow, will be coming to you. I'll put in the future value. I'm not going to do anything with type because we're just going to, there's no annuity here, so it doesn't matter, and I don't need to guess. So let me close up parentheses, and I get 27.23%. So, this one's not too hard, but this is probably a little bit easier to do the calculation. And I formatted these. When you do this, you're going to get 0.2723 something or other, and I've already formatted it. Here, it'll give you 27. It tends to round down. So if you want more decimal places, you have to expand them by using the key here. You can expand it or reduce the number of decimal places. All right, the final one I'm going to do is the number of periods. And again, this is a little more tedious. Again, algebraically, it's the natural log of the future value divided by the present value divided by the natural log of 1 plus the interest rate. But, again, if you don't put the parentheses in the right place, you're probably going to mess this one up. What is this telling us? This is saying we have $500. We want it to grow to 1,000. We have an interest rate of 15%. How long is it going to take us to get to that $1,000? So let's solve for the number of periods. I'll try and do it with the formula. So let me see if I can get this right. ln, okay, of FV divided by PV, okay, close that parenthesis, and one more parenthesis, divided by ln 1 plus the interest rate, and close the parenthesis twice. I get 4.95. We don't need that many decimal places. So let me just reduce that a little bit. So 4.96. Again, probably easier to put in the number of period, use the n period function. And again, PV and FV have to be different signs. So I'm going to say equals n period, rate is 15%. Okay, there's no payment here. PV is going to be negative 500. FV is going to be 1,000. We don't have an annuity, so we don't have to worry about the type. And let me see. Again, I get the same answer, and I'll just reduce the number of decimal places. So, again, much easier to do in Excel. Excel is incredibly useful for doing financial calculations. I see many students using, a sheet of paper and doing it by hand when it's so much easier to do it this way, especially if you have a lot of calculations to do. So I hope you find this useful, and I hope you learn to use Excel.